Welcome to this video. Today I'm going to show you how to create the mesh for future CFD simulation in OpenFOAM of centrifugal pump with impeller and volute. Okay, in previous video tutorial we have designed the volute for your impeller, and we have created the CFD domain for CFD simulation, and today we prepare one else inlet CFD domain for impeller, and we save it to step file, and we will be use this step file for creation a mesh in Salome Software. So let's start with creation of CFD domain, inlet CFD domain for our impeller. So let's go to part workbench, but before it we have go to sketcher workbench and create the sketcher. We will be using for this sketcher, create sketcher here on this face, and after that in part workbench we create the cylinder for our CFD domain before impeller. So let's create the sketch on this surface, click OK, and let's make this operation. We can import to our sketch this circles for creation this real circles of our sketcher. Okay, sketcher. Let's close the sketch, and for the sketch we have some conflicts because we have some troubles with, I think we have some troubles with constraint. Let's delete these constraints, I think, and let's close it. And after that let's go to part workbench and let's make the extrusion operation in x minus direction, and let's set the sum length of our cylinder. Click OK, and you will get this small inlet CFD domain. And now we have three different body. Okay, after that we can to save this all bodies to step file. So let's choose this blades, body and extrude files, and choose export, and let's export it to step format for using it in Salome Software for creation of tetrahedral mesh. Step CFD domain, save it, and let's click yes. Okay, and let's save also the project, and after that let's close this project and let's try to check our CFD domain step file. And how can you see here, we have CFD domain directory with our extrude, body and blades, with our three different CFD domains here in one file. So let's close the FreeCAD, and we have to open the Salome Software. Salome Software we can to download from official site. It's salome-platform.com. You can find it on Google, I think, and in my previous video tutorials you can find the Salome software where I showed where you can download it. Okay, so I will run the Salome. And here I have the CFD domains file, step file, which this file I will be used in Salome. So let's wait some time. And here we have the Salome, and let's choose the shaper model. You can use for creation of for preparation of geometry. For CFD simulation you can use shaper model or geometry model. It doesn't matter, but shaper is more state-of-the-art model for creation of geometry. So here let's do it in shaper model. In shaper, let's import here from CAD software. Here we have to use the step format. Click here and let's find our 3D model of our CFD domains. Here I will open this and CFD domains. I will click yes, and here we will get this CFD domains. In CFD domains, if you will open it, you can see here the different 3D models of our CFD domains. Let's check that we have 3 domains here, and for creation of the mesh we have to split these domains to 3 different parts in shaper, and after that we have to create the boundary names for your faces and export this mesh with boundary names to OpenFOAM and set up boundary condition for names of different boundary faces. Okay, so let's start with split explode of our 3D assembly step file, and let's go to part and let's create new part here. And to this new part we have to import one 3D boundary 3D domain, CFD domain for inlet, impeller or volute. So let's start with inlet domain. Let's activate this part 2. Let's go to futures, and after that let's make this operation import results. And for import results we have to choose our inlet domain here, choose it, paste it to this tree and click apply. And after that in part 2 you will get this import result. It will be only one inlet domain here. You can rename it to inlet or just domain 1. Okay, after that for this domain 1 we have to create the boundary names for your faces here. Okay, let's go to futures, let's go to group and let's choose this type faces, and let's choose the face, for example, here. Let's paste a name. It will be the inlet surface, and click apply and continue. You will get here the inlet, and you will get here inlet group. It will be using this. We will be using these surfaces for creation names for our mesh parts. Okay. After that, let's go to another side. Let's choose this face. Let's call it like EMI, because it will be the interface between this domain and the next impeller domain. It will be EMI interface in OpenFOAM. Let's call it EMI1 because it will be the first interface domain between domains, and _1, it means that it the first interface surface. After that, let's click apply and continue. You will get here two different groups, and let's create the walls. It will be the two surfaces. Let's choose here type face, click to this face, and press shift button on keyboard, click to this face, and you will get these two different face, and let's call it like a wall _1. Click apply, and here you will get this 3D model and inlet, EMI interface, and walls groups. And after that, let's go to menu and let's create new part, and here we will import impeller CFD domain. Let's do it. Let's go to features, click to import results. Let's open the part 1 group, and let's choose our impeller here. Let's click apply, and let's rename it to domain 2. Okay, here we have the domain 1. Here we will be using the name domain 2. And for this domain, let's create the names for our boundaries here also. The first will be the EMI surface, interface surface. Let's choose type surfaces, click to this surface, and let's call it like EMI1, 2. It means the first one mean the first interface between inlet domain and impeller domain. Let's click apply and continue. Let's choose type faces. Let's choose this face, and let's call it like EMI2, 1. It means that we have the second interface between impeller and Volute. Click apply and continue. After that, we have to create surfaces of our wall. All surfaces. We just click, press left button on mouse, and create the box. Choose all faces, and here we have to delete these two faces for EMI1 and EMI2 faces. Let's try to find it in our tree. I find the first, it will be the EMI, and let's press delete it, and let's try to find second surface. So we find it, it's 38 surface. Let's delete it, and here let's call it like a wall 2. Press but we can to check what surfaces we have in tree. by press show only. And how can you see? We have the all faces here without ME1 and ME2 surfaces. So let's press apply. Here you have ME1, ME2 and wall 2. So after that, let's go to part and create the last part. It will be the Volute part. Let's choose this part and let's repeat previous operation, import results. Let's go to part 1 and let's choose this Volute 3D domain and press apply. Here we have this Volute geometry, and let's create the names for surfaces. Let's choose the group and let's repeat creation of groups for our Volute. Let's choose type surface. Let's choose this face and it will be ME22. Press apply and continue. Let's choose this face. Let's call it like outlet because it's the last surface, and let's press apply and continue. After that, let's choose all faces of our Volute and let's delete the some surfaces for outlet and for ME interface surface. Let's delete this and let's try to find this surface of ME interface. I see it, this interface surface, and let's press show only again and let's check which surfaces we delete. How can you see? It looks that we have all faces without outlet and ME2 surfaces here. Let's just recall it like wall 3 and press apply after that, and you will get 3 different parts with our inlet, impeller and Volute domains. After that, the next step will be creation of the mesh. But before, I recommend you to save your project. Save as, for example, mesh project. Call it like mesh project. Click write yes, because I have previous mesh project file. And let's go to mesh. In the mesh workbench, you can see your 3D geometries here. If you press show and go here, you can see the inlet geometry, impeller geometry and Volute geometry. So if you open 3, you can see the inlet and walls here also. The names of your surfaces. So let's create the mesh. Let's choose this inlet domain for your geometry here, and let's activate the create all groups on geometry. It will import these surfaces names to mesh, and let's choose the geometry, the domain, and after that let's create the NetGAN 3D mesh, and let's set the parameters here. Let's set here the value. I think 006 will be enough, and minimum size 003. And if you will click OK, and after that let's go to 2D geometry. here, and let's use the NetGen 1D 2D. And after that, let's set the parameters here also. Use also 006, 003 for minimum and maximum size of mesh here. And for surface, we can to make the some refinement on your walls for your geometry. And let's choose the face here, and let's choose the wall 1. Click on face, and here you can set the local value of mesh size for your surfaces. We want to improve our mesh, refine it on wall 1 surfaces, and let's set here 003. Click OK, click apply and close, and let's try to compute the mesh. When mesh is computed, we can to check number of elements here. This number of tetrahedrons cells, and you can check it here. Let's click close. Let's check group on faces. How can you see? We have inlet mesh, EMI, and wall. Let's hide it here. And how can you see? We have some improvements of mesh on our walls and the more rough mesh on these surfaces here. So after that, let's create second mesh for our impeller geometry. Let's choose create mesh, choose this impeller geometry, activate create all groups on geometry. Here we also choose NetGen 3D and choose NetGen 3D parameters, create a new parameters for our geometry, and let's set here also 006, and I think here we can make some bigger value of mesh, 0005 I think, and set let's click OK for this. Let's go to 2D geometry and again 1D 2D. Let's create new parameters of mesh here. Let's set 006, and also let's set here 005. And also we can to set the local size on our faces here. Let's use on face, let's use wall 2, and here let's set 003. Click OK, click apply and close, and let's try to compute a mesh for our impeller. We have to wait some time because it's not very fast process. And now we can see that mesh was created. It looks good, but we have the really much number of elements here, I think. And if you will go to mesh information, you can check number of elements. Total elements, we have this number of elements. I think we can decrease. Let's go to edit mesh, and let's change. I think we can to make some bigger mesh on our walls. Let's set here the default and press clear plus compute mesh. Wait some time again. And after creation of mesh, you can see we have almost 100,000 elements here. I think it's enough for example of simulation, but it rough mesh, of course. Okay, so let's perform creation of mesh for our volute. Let's choose this volute geometry and activate the create all groups on geometry, and let's choose NetGAN 3D, and let's use the previous settings of parameters from our impeller. Choose this. And for 2D we have to use new parameters because we have the link. If you can go to local sizes, you can have here a link to our surface from impeller. And let's just to create here another parameters set, and let's choose here again this let's set this minimum size and maximum size for local sizes. I think we don't want to use it here. I think it's enough. And let's apply and close. Let's try to generate a mesh. And here we have the sum, not very much number of elements here, volumes, and yeah, we have our mesh. So we have this three. Let's check the group of domains here. For outlet, for example, for wall, it's all mesh. And now we can save these meshes separately to files, UNV files. So let's save the project, overwrite it, yes, and after that let's save separately any domain. I go to our project, and here I will create mesh folder, mesh 2, and I will save all meshes to this mesh 2 folders. I will choose the mesh 1, click export, and we have to use UNV file format. This format we can convert to OpenFOAM in the next video tutorial. Okay, let's use this folder and let's call it like domain 1 and save. Let's use this mesh, second mesh of impeller, export it to UNV file, and let's call it domain 2 and save. Let's choose this last mesh and click export UNV file, and let's call it like domain 3. Press save, and here you will get some different meshes files in UNV format. These UNV mesh files we will be used for generation native format of OpenFOAM polymesh, and we will merge them to one CFD simulation, set up boundary condition, and perform simulation, run the simulation. So it's all what I want to tell you about mesh generation from FreeCAD geometry, and in the next video tutorial we perform the OpenFOAM simulation. So thank you for watching, subscribe to the channel, goodbye.